Welcome to qnawire.
In this problem, we have a table of data that gives a U.S. population from the year 1790 to the year 1860, and we're going to use a graphing calculator to fit an exponential function to the data. So we start by going to the Stat menu, and then the Edit menu, and we type the years into List 1, and we type the populations into List 2. So once we have that, we go out of the list there, and then back into the Stat menu, and then we go over to Calculate, and we go down until we find exponential regression. There it is, and we press Enter. We're using List 1 and List 2, and inside the Store Regression option, we want to go into the Vars menu, go over to Y-Vars, that's Y variables, choose Function, and choose Y1, and that's so that our equation will be pasted into the Y equals menu so we can graph it. And now we calculate, and these are the values in the equation. And if we press y equals, we see that that has been pasted into our y equals equation and it's ready to graph. So now what we can do is we can go into the stat plot menu. Second y equals takes us to stat plot. We can press enter to go into the menu for plot 1 and then turn it on. So our scatter plot is turned on. And now we can press zoom number 9, zoom stat, so that the calculator will set us a good window. So here we see the scatter plot graphed and the exponential model graphed. It looks like a really good fit. Okay, so that was part A. Now it says we're supposed to estimate the rates of population growth in the year 1800 and the year 1850 by averaging slopes of secant lines. Okay, so we can go back to paper and pencil, and for the year 1800, what we're going to do is we're going to take the year 1790 and the year 1800 and find the slope of the secant line. And we're going to take the year 1800 and the year 1810 and find the slope of the secant line. Once we have those two answers, we're going to average them. So, the slope of the secant line between the years 1800 and 1790, that's just y2 minus y1 over x2 minus x1. We get 137,900. That would be people per year. And then we repeat that process for the times 1810 to 1800, y2 minus y1 over x2 minus x1, and we get 193,200 people per year. Let's average those two numbers, add them together and divide by 2, and this is our estimate for the rate of change of the population in the year 1800. We think at that time the rate of change was 165,550 people per year. Now we're going through that process again for the year 1850. So once again, I've taken 3 of the data points, 1850 and the point right before it. I'm going to find the slope of the secant line, and 1850 and the point right after it, and I'm going to find the slope of the secant line, and then we're going to average those two slopes. So we have the slope of one secant line, we have the slope of the other secant line, and then we're going to average those two numbers. So what we're saying is our estimate for the rate of change of the population in the year 1850 was 719,000 people per year. Notice the change from what it was in the year 1800, which was up here, 165,550, and what it is in the year 1850, significantly greater. Okay, so that takes us to part C. We're going to go back to our model and estimate the rates of growth from the graphing calculator. So what we want to do is we can go into the Draw menu, which is Second Program, and we can choose number 5, Draw Tangent. And we can draw the tangent for the year 1800. So type in 1800, press Enter, and the tangent line is drawn. And at the bottom of the screen, we can see the equation of that line. And look at the slope, 156,848.7. So how does that compare with the number we had earlier? This is 156,848, and we had 165,550. Okay, not too far off, about what, 7,000 or 8,000 off from each other. Now let's repeat the process for the year 1850. So we go back into the Draw menu, Second Program. We choose Tangent again, press Enter. We type in 1850, Press enter. There's the tangent line, and let's look at the slope at the bottom of the screen. 686,071. Okay, and what did we have before? 719,000. So our values were a little high compared to what we're getting from the graph. Okay, now for part D. Let's predict the population in the year 1870. So we go back to the calculator, and we press trace, and then we use the down arrow to make sure that our cursor is actually on the curve, not the scatter plot. So notice if I move left or right, it moves along the curve. And what we can do is we can type in the number 1870 and press enter. And we don't have it because we're probably out of range of our screen. So what we need to do is go to the window, and let's change our X max. Let's change that to 1900. Graph it again, and now we go to trace, and now we type in 1870. Oops, try that one more time. Go to graph, go to trace, put the cursor on the curve, and now we type in 1870. And what do we have at the bottom of the screen? Let's see, what would that be? 41,946,568. We're comparing that to 38,558,000. Okay, so this value is a little high compared to the actual value. So what would explain the discrepancy? Well, our model is not going to be accurate forever. It's just a model. It's not a perfect predictor of the population, and different things happen over time that will change and make the model less accurate.